we are going to measure the period of simple pendulum. Period of simple pendulum depends on what? There are 4 quantities we are going to search. One of them, mass of the bob. Second one, length of the string. Third one, gravitational acceleration. Fourth one is the amplitude theta. So length, amplitude, mass, and free fall acceleration. So they have effect on the period or not. We are going to try to investigate it. Now I'm going to do experiments about them. Now I'm going to show you my camera. First, we are going to check if length affects the period of a simple pendulum or not. I'm going to hold this. I prepared 2 pendulums for today's lesson. So this is a pendulum. I prepared that. So this is a vibrating, maybe in laboratory you see this iron thing. This is 50 gram mass. I suspended this 50 gram from a string. So I will make the length of the string first 30 centimeter, because I have a ruler which can measure only 30, not more greater than 30. I will make it 30 centimeter. Then we are going to measure the period. So let me make it 30 centimeter first. I am going to hold it from 30 centimeter. Then I will ask you to calculate the period, because we are going to do an experiment right now. So 30 centimeter in here. I hold it from 30. Then I'm going to suspend it from 30 centimeter. This length is 30 centimeter. Now I want you to see completely. This length is 30 centimeter. I just measured with my ruler. So now I want one of you to hold a stopwatch, or you can use a time. We are going to count 10 cycles takes how many seconds. After that, we are going to calculate the period, okay? So this is the equilibrium position, no vibration. Let me get this string. Now, who's going to use the watch? Anybody has a stopwatch in here?
Yes, teacher, I have it.
Okay, when I say start, you will start, okay?
Okay.
Of course, from that distance could be used this experiment. I will try, but okay. I will pull it very little and then release, okay? When I say 3, you will start. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many seconds?
10.67.
10.67 total time. 10 cycles divided 10 divided by 10, almost 1, is it? Period
Yes.
is almost 1. Okay, this was for 30 centimeter long this string. That distance, that length was 30 centimeter. But now I will double that. I will make it 60. So we will again measure. Period is increasing or decreasing or staying the same. I will check it. This is very long. Twice the length of the first one, this case. So you see it's very long, 60 centimeter. I made the length longer. So we will do it again. I am going to pull it from the equilibrium position and then release it. I will ask you again. When I say 3, you start your watch. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
It's 15.52 seconds.
Yeah, 15.52. 15 divided by 10. It's 1.5 seconds. What happened?
So obviously the period increases.
Increases, yes. Period changed. Yeah, increasing the length increases the period positively, but not directly proportional. You observe that. I doubled I doubled length, but period didn't double. If it were doubling, it would be 2 seconds. But
Yes.
initially it was
Just
1 second.
increases.
It is almost 1.5 times increases, almost. You will get the equation at the end, but now get this. Okay, for the first thing, we got it. Yes, length has an effect on the period. As length increases, period also increases, but not directly proportional. Second thing is the amplitude. Amplitude. So amplitude is the angle, remember. We are going to change the angle. So you are going to get surprised for the amplitude because everybody thinks amplitude causes a change, but the amplitude doesn't cause a change. Okay, let's do it now for the amplitude. You know the amplitude is the angle, is it? So I'm going to first pull it with a small angle and then release it. After that, I'm going to pull with a great angle and then release it. But angle must be less than
15.
That is the point. Mustn't be greater than 15 degrees. So that's why. So I'm going to pull with a small angle initially, then a little greater angle, but not greater than 50. Okay. So ready?
Yes.
I'm going to not change the length. I didn't measure the length because we don't care about the length right now. So we will keep the length constant, the same. Only angle will change. I pull very little, smaller amplitude. When I say 3, start counting.
Okay.
1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Teacher, it's 12.80 seconds.
Okay, very nice. Now this time I'm going to make angle a little greater. When I say 3 again, start.
Okay.
1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How much?
Sorry, teacher, it's 12.33.
Again, the same, is it?
Yes.
So, yani, if you increase the angle, it doesn't make change. Amplitude has no effect on the period of mass spring system. Yani, this angle, but less than 15, has no effect on the period of simple pendulum. Next one is mass. Mass has no effect. You will see that next lesson when we turn back, we are going to do that. So mass will have no effect on the period of simple pendulum. So only 2 things will have effect. Length has no effect. Amplitude has no effect. Mass will have no effect, but free fall acceleration, of course, without free fall acceleration, is it possible to make swinging? No. Free fall acceleration, yes, only two. Length and free fall acceleration will have an effect on the period. Period of a simple pendulum is calculated by 2 pi inside the root L over G. L is the length of the pendulum. G is the free fall acceleration at that point where the pendulum is located. So I will explain the Y cases, but Y cases are not frequently asked in music. That's why I will first solve some problems about this one, because this sample problem, page 32, yes, this is one of the problem which is asked this year, the first time asked problem. You need to know the height of a tower, but darkness obscures the ceiling. You note that a pendulum extending from the ceiling almost touches the floor, and that its period is 12 seconds. How tall is the tower? Okay, there's a tower. Let me draw the cases. Tower, let me draw. Inside is empty. I'm dark, sorry, not empty, dark. So you cannot see anything, but you observe that there is a pendulum. Suddenly, when you are walking on the floor, you observe that there's a pendulum suspended from the ceiling. And then you start vibrating the pendulum, and you observe that this pendulum has a period of 12 seconds. So what is how tall is the tower? In fact, height is asked to you, but this height is the same as the length of the string, is it? Or length of the rope that which is attached, which is used for swinging this pendulum. So if you find the length of the string or length of the rope from ceiling to the floor, so you are going to in fact calculate how much is the height of this tower. So which means you will calculate the length of the rope, and when you find the length of the rope, in fact you found what the height of the tower. Okay, so then period is given, so let's record it. Period is t, which is 12 seconds. It is given. And we know that, yeah, free fall acceleration is 9.81 g. Or generally in ministry exam, they use 9.8. Let's use as in ministry. 9.8 meters per second squared. Calculate the length of the pendulum and calculate height of the tower. Okay, equation for calculating a pendulum or a period of simple pendulum is t 2 pi root of L over G. Now from here on, you should go use some mathematics. This equation calculates t, but you need to calculate what L is. That's why you should get first L out of the root. How? You are going to square left side and right side of the equation. First do this way. So then left side t, square root of t. But when you are squaring the right side, there are 2 pi and root of L over G is multiplied. You should square both to both and pi and root. You should square them all. So square of 2, 4. Square of pi, pi squared. So square of root of LG. Let me go step by step because this is important. Students are doing mistake in not physics part, but in math part. So then squared. That square and this square root will cancel. So you will get t squared is equal to 4 pi squared multiplied by L divided by G. Then you will calculate L cross product equation. Let's continue in here. T squared times G is equal to 4 pi squared times L. What is the question? L. So then which means divide by 4 pi squared because you need to calculate L. Both sides is divided by 4 pi squared. Simplify them. So then L is going to be t squared multiplied by G divided by 4 pi squared. I mean, if in this section, they will ask you in some questions t. It is easy, just you are going to put L and G into the equation and then you will get the square root multiplied by 2 pi. But sometimes they will ask the quantity which is inside the root. If it is in this case, you should do this mathematics. There is no other way. So you shouldn't do any mistake in calculations. So you should let the quantity which is calculated alone in here, as I did, L is equal to t squared G divided by 4 pi squared. And the rest is your calculator. So let's insert the given. T is given as 12 squared. G is 9.81 divided by 4 pi squared. 4 times pi is 3.14 squared. But remember, denominator must be in bracket. So then if you do them all, you will get the length as, it's written in here, 36 meters. If the length of the rope is from floor to the ceiling is 36 meters, so which means height of the tower also must be 36 meters. So this is how we solve the problems. As you see, they are not so hard. This is the hardest one. If you say a question is hard, this is the hardest one. There's no other questions harder than this in this section. The rest are very similar. For example, practice 1 is asking about the length again. We know how to calculate the length. And in here, in practice 2, you will calculate period and frequency. First, you will get the period equation. You know that t is equal to 2 pi L over G. And the frequency is, remember, it was 1 over t. So you will first get what period is. After that, you will get the frequency 1 over t. I mean, A, B, and C. You will do them. That's why I'm not going to do them. You will do it. This is so easy. Only thing you should know in here, maybe a little different. They gave in the book the equation for period. Yani this equation is given, but you can get the frequency equation. Yeah, it is the ministry exam question as well. This year, previous year, they asked, which of the following is the equation for frequency of the pendulum? This is the equation for period of the pendulum, 2 pi inside the root L over G. But we know that frequency is equal to 1 over T. What does it mean? You are going to flip this equation. Yani you are going to flip every, the term here. Normally it is 2 pi over 1. It's not written here, but you are going to flip this. 2 pi over 1 will be 1 over 2 pi. Inside the root, normally in the period equation, we have L over G, but in the frequency, it's going to be G over L. Yes, this is what they do. In some ministry questions, you will see that frequency equation is going to be inverse of period equation, which is going to be 1 over 2 pi G over L. In addition, better to know this for the case if it is asked in ministry exam. Pendulum that moves through its position, its equilibrium position once every 1 second is called seconds pendulum, which means pendulum is, let's think this is the equilibrium position. So this pendulum is passing in 1 second to the left. So once every 1 second, 1 second to the right. So one cycle takes how many seconds in this case? 2 seconds. So that's why period of seconds pendulum is 2 seconds. Its period is 2 seconds. Ministry exam question. So period of a seconds pendulum is 2 seconds. Why is it called seconds pendulum? Because these pendulums are used in, maybe were used previously in the clocks. Every half cycle going to left 1 second. 1 to the right, 2 to the left, 3, 4, 5, 6. So every half cycle is 1 second. 1 cycle takes 2 seconds. So they are used, as I said, in the very, very long ago in a pendulum to measure the time. And once they ask about what is the frequency of the seconds pendulum, if the period is 2, frequency is calculated 1 over T, is it? So 1 over 2, which is 0.5 hertz. So 0.5 hertz is the frequency of a seconds pendulum. And this is a name. That pendulum's name is seconds pendulum. 1 second left, 1 second to right, 1 left, 1 right, 1 left, 1 right. So then you can measure the time by this pendulum as a clock, many, many years ago.
Teacher,
Yes, please.
So, the pendulum is usually called seconds pendulum.
Yes, name of the sound in seconds pendulum. It's count in seconds. Seconds pendulum means count in seconds.
So because of its counted in seconds, that's why we call it seconds.
Yeah. It's not first, second, third. It's count in seconds. That's why it's called seconds pendulum.
Okay.
Others are easy. You are going to calculate the free fall acceleration by using the equation. That's why I will skip this one. But one conceptual question in here, better to know that because it's also ministry exam question. This conceptual one. The free fall acceleration on the surface of the moon is approximately 1/6 of the free fall acceleration on the surface of Earth. We know that on the surface of the moon, free fall acceleration is less than on the Earth. And in this question, they give that it is less by a factor of 6. By a factor of 6, it is less than Earth. Compare the period of pendulum on the Earth with that of an identical pendulum set in vibration on the moon. So there are 2 identical pendulums. One of them is set into vibration on the Earth. The other one is set into vibration on the moon. So compare their periods. So which one will have a longer period, greater period? Which one will have a smaller period? And then how much, by what factor, greater or smaller? So remember, I thought that because the free fall acceleration on the moon is smaller, according to the period equation, we know that equation T is equal to 2 pi root of L over G. As G gets smaller, period gets longer. That's why on the moon, period will be longer than on the Earth. This is the fact you should know. Period of the same pendulum on the moon will be longer, greater than the period of the same pendulum on the Earth. But how much greater? So we will use this ratio. Question says that free fall acceleration on the surface of the moon is approximately 1/6. 1/6 means 1 over 6. Yeah, if you are saying that free fall acceleration on the Earth is G, free fall acceleration on the moon is going to be G over 6. 1/6 means G over 6. Yeah, you are going to multiply G by 1 over 6. So 1/6 means this. Then I'm going to calculate the ratio. Calculate the ratio. Compare the period of the pendulum. When it says compare, the question says compare. You can compare the quantities by dividing them one another. You are going to calculate the ratio. So I'm going to divide period on the moon of this pendulum to the period of the Earth on this pendulum. I will divide them. I will find what is the ratio, which one is greater, which one is smaller, by what factor greater, by what factor smaller. I can get it. Let's write the equations. Period on the moon is what? 2 pi inside the root L. L is the same for both pendulum because they are identical. But G's are different. So I will simplify 2 pi's. I will simplify, then I will flip this upside down. Remember, here is the denominator, here is numerator. So you should flip G over 6 for moon as 6 over G. Yani 6 times L over G is in here, but below is only L over G because only 2 pi simplified. Both are normal inside the root. Directly you can simplify L over G's, in fact, but I did L a little longer. I get the 6 out of the root and wrote L on. Root 6 multiplied by root L over G for numerator. Denominator is L over G. Now L over G and L over G simplified. You got the answer as root of 6. So period on the moon is greater than period on the Earth by a factor of root of 6. Period on the moon is greater or longer than period of the same pendulum on the Earth by a factor of root of 6. Give a number. If a pendulum has a period of 1 second on the Earth, on the moon, this pendulum will have a period which is root of 6 seconds. If a pendulum has 2 seconds on the Earth, the same pendulum will have a period on the moon which is 2 times root of 6. So it's going to be like this, and this is one of the ministry exam questions asked, I think 2017, this is asked the first time. Yes, period of the pendulum on the moon is root of 6 times that of the period of the same pendulum on the Earth. This number will never change between Earth and the moon. This number will be always root of 6.